right, I'd like to introduce Robin. He's a scientist with the San Francisco Estuary Institute.
Well, thanks a lot. Hey, those were great questions. That was fascinating. And yeah, so I'm here from the San Francisco Estuary Institute with my colleague Scott Dusterhoff, who's going to take the second half of our talk. And we're a nonprofit environmental research center that was set up by many of the agencies in the region, local agencies, state agencies, federal agencies, as well as NGOs and business interests to be a centralized, impartial center for kind of the information needed to manage the estuary and its watershed. So we work with everybody and try to make basic information available to help answer these challenging questions that we all face. And being here, I do want to say, we really look to Marin County and some of the things you guys are doing here with the watershed program and the stuff in Lower Novato Creek. Those are real trend-setting activities that the region, are forward-looking for the region. So really good stuff here, and we're excited to be a small part of it. So I'm going to talk about kind of the context that has created both the opportunities and the challenges that you face today. And talking about what we call historical ecology, and then kind of looking towards the future. How do we make the systems a little more resilient so they're not, we're not fighting ourselves in the different spots with the kind of impossible situations we've created, often by accident over time. So, but why do we even care about history? Given that we're concerned with the here and now and these current challenges, in these highly modified California landscapes like here. And why is a picture like this from 1870 or a map like this from 1854 at all relevant to this place that you know and love? Well, because those things help us understand how the system worked and how we've gotten to where we are. We have a lot of challenges that are related to that history. So subsidence, as you may know, many of these areas, essentially all of the areas that were diked. So this area was diked off with these levees that Lori and Liz were talking about to reclaim it for agriculture primarily, also some residential housing. And once it's removed from the tides, that organic matter starts to oxidize like your compost pile, and it just goes down over time. It subsides. So this area is getting lower every year, every day, as the seas are going up every day, every year. So they're going in opposite directions. So this is a challenge. It's going to become more of a challenge. So we have a system that we got to think through why it's working that way. Sea level rise. Sea level has been rising in the world for the past 10,000 years, right? It's just since the last ice age. Glaciers have been melting, but it's speeding up, and it's going to really speed up in the coming decades. So that's a greater challenge. We have a system that was designed, largely a century ago. The concepts came in, or around 1900 or so. These systems were established, the levee system. And sea level rise is continuing and going to be even more. So that's a challenge. And then ecosystem restoration. And there's tremendous potential here with steelhead, remarkably in this creek still, despite everything, with clapper, well now called ridge-raised rails, and salt marsh harvest mice in these marshes, very small marshes, but potentially connected to other populations in the north and south. And then the flood risk, which is complex and, as you heard, and changing over time, and somewhat a response to how we've altered the system. So all of these things kind of draw on how we've modified the landscape. And we can look to understand that to help shape the future. So historical ecology helps us understand how these systems work, to help us develop creative strategies for the future, exactly as you hear the DPW starting to do. Already some of the work done in Ross is in that direction, and the kinds of things you're hearing about here. So often nowadays trying to integrate natural processes more effectively so that we're not having to engineer and re-engineer and dredge again and again and again, but we're maybe using the natural forces to maintain the system, and with the expectation that's also going to be better for the ecosystem and sometimes help you get permits more easily. Because when you're having to tear apart the ecosystem every few years, it's creating a mess, and it's also really expensive. Plus, the other reason we do historical ecology is kind of fun, getting into all these documents. So hopefully you'll enjoy that. So just a little bit of a whirlwind tour of some of the documents we got into for this study. We go to archives, the ones in Novato, libraries and historical societies throughout Marin, at UC Berkeley, Sacramento, even Riverside has an important archive now. So we gather material from all over California, and online databases from really throughout the world. This is probably the first really detailed map of Lower Novato Creek done by the U.S. Coast Survey, which is the first federal mapping agency, and became NOAA, actually the National Oceanic and Atmospheric Administration, and made these really accurate maps, remarkably detailed. So this is the creek here, and just to give you a little more information, this dotted line here, that's the line of mean low water. So that means at low tide, there's still water in this channel, so you would see water there, but all this area would be mud flat that was exposed, and all of this marshland, this is all the tidal marshland, and these are the channels, the tidal channels that brought water in and out on the tides. And these were natural ponds or pans over in this area. So this is a great map for us. We've studied them really well. We know the individual surveyors who made them and what their predilections were and tendencies and weak spots and strengths. Maybe more than we need to know. But it just stops right here. No good reason. They just sort of ran out of gas. And so what about the rest of the world over here? Well, luckily the next guy who came through in 1897, and amazingly the same surveyor was involved in both. 40 years later, this guy Rogers, he was pretty remarkable career. Although he didn't do the greatest surveys, unfortunately. He had longevity though. This map, you can see a lot has changed. These are all levees that have diked off this whole area, although this area remains tidal. And then this area is fascinating, we'll talk about this more, has actually built out because of the hydraulic mining debris coming down from the Sierras, which built out much of this whole area, a surprising amount. It starts to fill in some of the detail over here that we didn't see, and you can see there's railroads, and they actually show some of the vegetation patterns a little bit more. So another highly accurate map. But you know what it doesn't have? It's just a flat map. So we don't know, like, for example, how deep was the creek? You know, which is the obvious question that comes up for capacity of floodwaters. So this is something we weren't able to find a detailed survey. Sometimes with a bigger river, there will be actually soundings, right, for boats, for navigation, like the Sacramento River. There'll be soundings from very early on. We didn't find that here, but we did find information like this. This lithograph from, I think this was 1910-ish. And you can see boats, scow schooners, coming up all the way to the landing at the rancho. And so that gives us some evidence in and of itself, perhaps not the strongest evidence because it's just a drawing, but they probably didn't totally make that up. And that means that there's water there, at least a certain amount of water, maybe at least a few feet at low tide. These are fairly shallow bottom boats, so it doesn't mean there's a whole lot of draft. But that gives some suggestion that this channel looked pretty different than it does today. You probably can't imagine bringing up boats like that and actually relying on navigation. In fact, there's a whole display out there. It's really fascinating by one of your neighbors, forgetting her name, about navigation. Sorry. Yeah, everyone knows you, I'm sure. Yeah, about navigation. Friends of Novato Creek, wonderful group. This is a really neat display getting into this topic even further, the history of navigation on the creek. And that's often a pretty important bit of information to sort of prove and kind of convince ourselves that this stream used to have that kind of capacity. There's another picture, even earlier, of a schooner well up on Novato Creek. Another question, the back edge wasn't really illustrated by those maps, and we found some great photographs from 1945 or so. You can see the truck down there, vintage. And these help create a picture of the back edge of the marsh, which is actually really important ecologically, because you get a lot of the biodiversity in this intersection between tidal marsh and then the terrestrial environments, right? You get kind of complex ecosystems. And then it's also really important for sea level rise, because that's where the refuge is for tidal marsh species that can't fly, have to get up here in a big high tide. Otherwise they drown. You can see there's not really anywhere to go. So this area is really important, and the character of it is important. This is a really unique area in the bay, it turns out, because in very few places around the bay did you have marshlands. The bay was made up of marshlands throughout the region, 200 square miles. But you had almost no other places where you had a dense woodland coming right down here at Black Point, right down to the edge of the bay, with the marshes. So that's a really special thing. So that's partly what we learned from historical ecology too, is what's special about this place, this part of the world. What are the sort of natural resources that make it unique and might be able to be recovered or retained? And so this kind of contact could be recreated with the kinds of plans that are being talked about. Here's coming a little more towards the south, and you can see a really different kind of transition zone. We call it the transition zone between the marsh and the uplands or the drylands. And here you can see sort of scattered oaks and more of a grassland area. Again, a really important kind of place for species that use the grasslands and the wetlands, and where tidal marsh needs to go as sea level rises, ideally. So we put these and many other sources of information together and make a map, a GIS layer, computer map that we can overlay and put in and compare to our contemporary maps, right? And start to get quantitative and be able to analyze things and contribute that to the engineering parts of these projects. So this is a map of the Novato Creek Baylands circa 1850. And I'll go through and show you some interesting things about it. The light green is tidal marsh. That's the almost 5,000 acres of tidal marsh that there was. A couple thousand, maybe close to 3,000 acres of tidal flat. These are the channels. So one of the most important things that's already been sort of a theme today is this channel network, the tidal channel network, which I can't remember the number from our report, but I think it was on the order of 1,000 miles. Now that seems like a lot. How many miles was it? I think it's open to that page. There was hundreds of miles of tidal channel, or maybe it was 100 miles. It was probably 100 miles. There was a lot of tidal channel here. And the point being so as Liz was saying, the water goes into those channels and out twice every day. It's a massive volume of water, much greater than what's usually coming out of Novato Creek, because that's a small trickle compared to this massive flow. That's what kept this channel big and wide, was those tidal flows in and out, regular clockwork driven by the moon, gravity. So that created a tidal channel that was big enough for boats to come up regularly. And so here today, we go back and forth, we have, and Scott will show this more quantitatively, we have diked off the whole system. So the only area for the tides to go in is the narrow strip just along the creek. So the water, there's really very little action there. There's very little what we call tidal prism, right? And so as a result, this happens throughout the bay, it has to fill in with sediment because there's no force to keep that sediment out there. So it's a natural response of the system, and it's just going to happen. And we can just keep digging it out again and again, but it's just going to refill. But you have this amazing potential here that you actually could recover much of that function. Another thing to look at here, which Lori also pointed out, we found that these creeks over on this side, we're actually right, I think we are right about here right now, Arroyo de San Jose and Pacheco, they just sort of spread out over here, sort of diffused into the marshes. And that's a really important phenomenon that we found actually throughout the Bay Area, is that many of the streams, it's a Mediterranean climate. There's not a lot of flow in these systems year round. So they often just kind of fizzle out and spread their water more broadly into this wetland system. And the tendency as we developed flood control systems would just connect everything up, which is great for reducing the flooding here, but it diverts water into these sort of pinch points, and you deliver all the water to the same spot. So now, as I pointed out, Pacheco Pond spills into, the water diverts through here into here, and then into Novato Creek, increasing your challenges when you have flow coming from all those spots. So one of the themes that comes out of the historical ecology is that, gosh, maybe these used to be decoupled, we've connected them, and now that if this area is actually being restored, and there's not such a driver to keep water out of here for agriculture, it might be, it might make sense to actually divert that water this way. Actually would have some benefits for the marshland that's being restored there, because fresh water is actually good for these systems and helps them grow vertically faster for sea level rise. So you can see there's a lot of, as we change our priorities for this area and have different needs up here, kind of makes sense to think about how the system is organized, structured, designed. Another theme, thinking a little more from the ecological side, is that you had really different types of environments out here. Now it looks kind of similar. It's all sort of diked and grassy. You had these areas that had a lot of tidal channels. You may have noticed this already. This area looks really different from over here. It's, so this would have been really good for steelhead. When they're coming out of the watershed, they're tiny. They go out to the big bay, they're going to get eaten. They want to fatten up. You could have all this area, you could go in and get a lot of food before you go out to the bay. This area is good for clapper rail, or ridgeways rail they're called now, endangered species, lives in channels. Interestingly over here, this is another unique thing about your area. It had this huge concentration of natural ponds or shallow lakes in the marshland that would probably evaporate in the late summer and become pans or sort of alkali areas, salt pans. Really important for shorebirds. They're probably where all the shorebirds that are in the salt ponds now used to be. I mean, not just there, but in places like that around the bay. Those are kind of the original salt ponds. So don't quite know why there were so many right here, although it probably has to do with this interesting feature, which is if you notice the channels, there's no channels over here on the edge. There's a natural berm built up on the edge of the marsh, we infer from these maps, because of the wave energy building up the marshes here. And so all the drainage comes around from this side, if you notice. Like this channel doesn't drain this way, it goes all the way back here, and all the way back here. So that actually is sort of a natural protective feature that was built there that we could regain again potentially if the wave energy and the sediment supply work that way. So, so that leads us to think about different kinds of restoration strategies in different parts of this area who have different benefits for the ecosystem. One of the last couple of points I'll make before I turn it over to Scott is another unique thing about this area is all these islands. There are these little islands and this big one, Deer Island, within the marshland, and that's probably a unique concentration to this particular spot. There were a few islands in other parts of the bay, another one over here, but probably really valuable ecologically. Places for refuge. Birds can nest out there, with some safety from predators. High tide refuge. So none of them have the bay. The bay doesn't touch them anymore because they're all disconnected. But they could be connected once again, and that would be a pretty unique resource and really quite beautiful and unique to the region. Again, really important for also sea level rise places for the marsh to go, although they're relatively steep. And then another just sort of key thing to understand about this system is how this margin, so this, if you notice, so there's a point of land right here that I managed to cut off, but it's right about here. And then there's this point of land here. And the edge of the marsh is pretty much a line between them. And then there are these huge mudflats. But the marsh, had been here at that time. But now it extends almost a mile further out into the bay. So that means that floodwaters have to get through all this area too. And that there's a lot of more land to deal with out here. So it's a pretty amazing expansion of the system. And that's due to hydraulic mining debris coming from the Sierras and the gold rush. So that's kind of changed and so, we've kind of put our levees out here then much closer out to deep water and bigger waves and higher energy, kind of in harm's way. So we used to have this protective mud flats here. Now we have very little mud flats there. And we have, we kind of maximize dry land, but also put it to some extent in harm's way without the protection. In general, this whole area used to be a protection of marshes to dissipate waves before they got to the land. And now it's kind of more of a hardened structure that is going to be a challenge to protect over time. So now I'll turn it over to Scott to do the second half, I think more or less right on time, right?
Okay, so on to the second part of our presentation. So what I'm going to do here over the next few minutes is kind of take what Robin just presented to you and move it along and show you how we use that information to then inform some high-level concepts of how Lower Novato Creek could look and some basically how it could be restored and compare some of the information about the historical area and length of tidal channel to contemporary and use that as a way to come up with some restoration targets. So the information that Robin just presented and what I'm about to present you now, all of this was done within the Flood Control 2.0 project. Okay, so Flood Control 2.0 is a regional project funded by the EPA with one primary project goal. It's essentially to help develop a set of tools and a process for helping create visions for redesigned flood control channels at the Bay interface that address multiple needs. Okay, so this is a project that's region-wide. We're working with Marin County as well as several other flood control agencies around the Bay to come up with these visions, essentially kind of high-level landscape scale visions where we help come up with these concepts that would lead to a multi-benefit channel. Okay, multi-benefit meaning it meets flood control needs because that's top priority, and then there's also improved ecological functioning as well. And so down here I have all the partners, SFEI here funded by EPA, and then the rest of the project partners as well. And so then in terms of what this project is doing with Lower Novato Creek, as we've already mentioned, the concept here is to work with Marin County as well as a set of technical advisors. Okay, it is not just Robin and I and Liz and Laurie and we get this all done. There's a lot of moving parts here and a lot of people involved. So it's all of us getting together to look at the data that we've compiled as well as data that others have compiled and other analyses to help develop a long-term vision for these, for a resilient landscape, a resilient multi-benefit channel. So the first thing that we did to kind of get to this landscape scale vision was to compare historical conditions to present conditions, okay? And so we did that by looking at several ecological metrics. And the first one is habitat type. Okay, so this is just a shrunken down version of the map that Robin's been showing you. So you've seen all the habitats already. So this is the historical condition around mid-1800s. And then this is what we have now. This is very similar to what Robin has shown you already, but now you actually kind of see the habitats highlighted. So just the kind of big thing that jumps out at you, whereas historically there was, as Robin's mentioned, 4,500 acres of tidal habitat. Much of that is gone, and now it's confined to just within the, between the levees along the channel. And again, Robin has pointed out historical shoreline, that's where it was, and this is where it is now. And so then we essentially were able to get a little quantitative on this and actually compare the acreage decrease. Okay, so historical full acreage for all the habitat types, around 8,000 acres, and now looking at everything out there, it's about 3,000 acres, but that includes what we're calling here these open water and these non-tidal vegetated areas, so these man-made features. Total 3,000, but if we're looking at the features that used to exist, more like just 1,000 acres of habitat. Okay, so this is habitat types, historical, modern. And then if we get to the channel length, it's the same type of story. Robin's already gone through this a bit. Historical, very dense tidal channel network shown here in red. The main Novato Creek, Lower Novato Creek shown here in blue. Again, this is what it is now. And then this is the decrease in miles of channel. So the main stem channel, this main Novato Creek, not much difference, right? It's really the big decrease in the tidal channel network, just a few small tidal channels remaining. And then the third metric we looked at is this marsh upland transition zone. And Robin also talked about that already a bit, and we also call that ecotone for short. So historically, again, the map and what we highlight now in these dark lines is that transition zone, okay? So where the marsh touched the uplands. Okay, so there were essentially two types. There were, in gray here, we're calling this the narrow type, okay? So this is where the marsh was touching what Robin was talking about, these bedrock islands, okay? That was very steep transition zone. And then where the marsh was touching more gently sloping land, those were the broader transition zones. Okay, so these areas are important, as Robin mentioned, for habitat, but also these are the areas, especially these kind of lower gradient, broad areas, these are where the marsh is able to migrate as sea level rises. Okay, so these are really important features. Historically, kind of ringing the entire baylands. Presently, not much left, okay, and then here is the decrease in total mileage, just very little left, just up here, essentially right around the corner from the mouth of Novato at the mouth of the Petaluma River. So then what we did is we took this information and some other studies, and we got with our regional advisors as well as Marin County, and we sat in a room for a day, and Robin and I and our colleagues presented this information, and we put our heads together with our advisors who are very knowledgeable about bay ecosystems as well as Novato Creek, and came up with what we're calling the Baylands Vision 2100. Okay, so this is a snapshot of it. I'll walk through it in a second, but before I do, I just want to point out that it's Visions 2100 because the concept is this is a long-term vision. Okay, these are high-level concepts that we're saying that it would make sense to shoot for in Lower Novato Creek over the next 85 years. So that's the one thing to think about. The other thing, back to what Laurie talked about in her part of the presentation, is what's going on now with the alternatives analysis and kind of the shorter-term things that are happening. So the concept here is that this is kind of the longer-term vision, okay, and then what Marin is currently doing with their consultants is over the next 50-year time span, kind of the shorter term. And so what's happening over the next 50 years will then essentially be the launching point for ultimately getting to, ideally, some of these vision concepts. So let's walk through what we have here. So the first thing to point out, I'm going to kind of just walk around this kind of counterclockwise. The first thing this vision calls for is removing the levee here on the north side of Novato Creek, okay? And so as Robin mentioned earlier, if you get that tidal marsh area back, that's going to increase the tidal flushing in the channel. That'll get a lot of that sediment out. That'll give it capacity. That'll help with flood control, but it'll also help with habitat. But in order to make this work and to get all of this historical baylands reconnected, this vision also calls for turning Highway 37 into an elevated causeway, okay? So this sounds great on paper, it's easy for us to say, but in practice we know that would be very difficult. So that's one thing to keep in mind here with this vision. It is kind of high level, kind of shooting for things that we think make sense for this landscape to aim for, not considering how difficult some of these things will be. So we fully acknowledge that turning Highway 37 into a causeway, there'd be some difficulties there. The next thing to point out is within the vision is the reestablishment of these transition zones, that, like I just mentioned. So if we open up this levee, open up Highway 37, and also open up this levee here south of Novato Creek, all these dashed lines show where you could get some historical transition zone areas back. The next piece of this vision is what we call here this, I'm kind of lumping these two pieces together, the orange and the kind of blue area here, the creation of a depositional fan and then the creation of this horizontal levee. So let's walk through this a bit. So we know that a lot of sediment currently deposits in this part of Lower Novato Creek, and that's likely going to continue no matter what we do downstream. So what this vision calls for is taking that sediment and then using some of it to create a depositional fan feature here. Okay, so that has habitat value. It allows you a place to put that sediment, and then it's also an area where the tidal marsh can then migrate inland as sea level rises. So another thing to point out is if we open this area back up to tidal action, Novato Sand is going to have to do something with the water that they currently put out here to irrigate the pastures. So this vision calls for taking some of the sediment that comes from this zone here that needs to be removed, building what we're calling a horizontal levee. Okay, so it's essentially just a broadly sloped levee that can not only protect this vital infrastructure from flooding, but also provide some habitat. So building the levee with some of this removed sediment, and then using this Novato sand water to filter it through the levee to help create that habitat and help create brackish marsh. Okay, and then the last piece of this vision, and Robin talked about this towards the end of his presentation, is reestablishing some of these marsh ponds that were historically here. Okay, so as Robin pointed out, Pacheco Creek and Arroyo de San Jose currently are diverted into Pacheco Pond. But again, this long-term vision, this is something that we're calling for, shooting for, 85 years into the future. We're recommending diverting that water and then bringing it back into this part of the marsh so you could actually reestablish some of these marsh bands that were historically there. And then the last thing I'll point out is that we know that any of these vision concepts that we have here are going to need to be coordinated with existing restoration projects. And there's currently a plan for restoring this part of the Baylands. Belmarin Keys Unit 5 is what it's called, and Hamilton Wetlands has already been restored and been breached. So we just definitely want to acknowledge that this is not the only game in town, right? There's other things going on in Lower Novato Creek, and so whatever concepts that we come up with within the process that we have need to be coordinated and will be coordinated with these existing restoration projects. Yeah, I guess one quick thing to know the difference between the north side of the creek and the south side, and I think we have a figure here. I can show it if you all like, but this area down here is so much more subsided. It is so much lower than sea level than this area up here. That's not to say that there's no subsidence up here, but this area, the elevation is higher. So in concept, you would not need to use as much sediment, if any sediment, compared to what was needed or what will be needed to actually restore Belmarin Keys. Yeah, it's very subsided in the southern part. And so what this purple line is, again, kind of drawing from the most recent version of their alternative. It's the levee that their design calls for to protect Belmarin Keys. So then next steps were to take this vision and then do the ecological metrics analysis on it. So to say, okay, we know what past was, we know what present is, let's run that analysis on this to see how much benefit we could get from a habitat perspective from applying these vision concepts. So the first thing we looked at was habitat area. Tidal marsh area is the one that I'll show here. So this is just a scaled down version of the plot I showed before with just some additional data. So again, historical tidal marsh habitat, about 4,500 acres, modern, and then this is what could be attained with this future vision, okay? And so important to point out here what I mean by historical and modern shoreline. So we think you could get about 3,000 acres back if once this levee is breached and this area, as the gentleman was just discussing, is going to evolve as it will. One possibility is that as it evolves, the shoreline will march, and go close to what it was historically, which is somewhere around here. If that were the case, this is how much marsh area you would get, okay? If the plan evolves as currently envisioned, and the shoreline stays out here once they breach the levee for Belmarin Keys Unit 5. This is about how much tidal area or tidal marsh area you could get. Okay, so that's why we show a range here, because we have no idea how it's going to evolve right now, and this is just to kind of give you all an illustration about what we think about the minimum and about the maximum could be. So this is tidal marsh area, tidal channel length, historical, modern, and then again the future vision, having two values because tidal marsh length is a function of how much tidal marsh area you have. So just like area was a function of where that shoreline is, length is the same. So if you get the historical shoreline position, you have about 80 acres or 80 miles, sorry, of that tidal channel network you could get back. If that shoreline stays all the way out here, as envisioned in the restoration design, you could get approximately 140 miles of tidal channel back. And then the last thing is this transition zone length, or the ecotone length, okay? So again, historical, modern, and then in the future, okay, we have three colors this time. Okay, the dark is that steep, narrow ecotone, so this is where the transition zone is up against those bedrock islands. The green is where the transition zone is up against the kind of broad areas. And then this purple is the transition zone, or the ecotone you could get back with this horizontal levee. Okay, so there is habitat value there the horizontal levee is protecting infrastructure as well as providing habitat, so we include that in this estimate of how much transition zone length you could get back. Okay, so for transition zone, you're not going to get nearly as much back as you could for marsh habitat and tidal channel length, but it's such a vital habitat and such an important piece of the ecosystem. Getting any back is considered success. So, so that's the story there. So that's kind of a summation on what Robin and I and our colleagues have been doing, thinking about Lower Novato Creek and the historical ecology as well as the contemporary and potential future ecology. So in terms of what's coming out of the analyses that we're doing, the first thing is this Novato Creek Baylands Historical Ecology Report, which we put several copies of outside. So the first 10 people here got a door prize. Congratulations. It is also going to be available on our website, and I'll show you that website address here at the end. This is what it looks like, and for those that weren't so lucky to get a copy, just some screenshots of what's inside. So some of the historical sources that Robin went through, also walking through the habitat features and then some of the interesting things that we found in our examination of the historical landscape. The second thing is this visions report. Okay, so the historical ecology then sets up the vision report, and this vision report will walk through the process by which we gathered historical and contemporary data, sat down with our advisors, developed the vision, and then came up with the metrics for what habitat improvement you could get by applying the vision concepts. And that'll be coming out in July of this year, so just in a few months. And this is kind of the punchline of the report. Again, the vision concept I just showed you, and then in much more detail about what each of these concepts entails and the benefits associated. Here's the project website. It's at SFEI's website, Flood Control 2.0. You can feel free to email Robin or myself for any more information. And I just wanted to also close by letting you all know that the recent issue of Bay Nature has an article about Flood Control 2.0 in it, and Liz Lewis has some great quotes in there. Here is a snapshot of the first pages of the article, and it is now available for free on their website. So I encourage you to go to baynature.org/articles and get a copy of the Flood Control 2.0 article. Thank you.